Your boy, Marcus Kim, coming back at you again with another video on SpriteKit. If you haven't been here before, we are learning the SpriteKit framework by creating an app called Asteroids, which is a clone of the 80s arcade game Asteroids. Let me go ahead and run the app real quick, just so you know what we're talking about. It's pretty straightforward what we have so far. We have all the screen elements onto the screen, like the asteroid, we have the score, we have the spaceship, we have the enemy spaceship, which is just a piece of poop in our game. You'll understand what I mean in just a second. But basically our app is exactly like the game Asteroids, except it has different UIs. So the UI you're going to see has asses instead of asteroids, hence the name Asteroids with two S's. Asteroids. Asteroids. So if this would please run. Hopefully we're not getting a runtime error right now. I don't know what's going on with my app lately. To be honest, why it's so slow, I have no idea. My code is somehow not optimized or something. There we go. So this is our game, the Asteroid game that we are building. See, it's a 2D game, and when you shoot missiles, the asteroid breaks apart. We don't have collisions handled exactly how we want them to be handled just yet. We have to fix the category bit masks to control the response whenever there's a collision. So ideally what would happen is if you remember just a second ago, all those big asses you see on the screen, well, those aren't supposed to just disappear when a missile collides with them. They're supposed to break down into medium asteroids, and then from there the medium ones are supposed to turn small and the small ones disappear from the screen. So that's what's supposed to happen. In a previous version of our app, that was all working fine, but we're refactoring here. We want to get the same functionality of the ever smaller asteroids, but have that functionality encapsulated in this class right here, this asteroid class. So let's see how we're doing it right now. Okay, so here we have, this is where we're handling the collisions. We have different categories, the missile category and the asteroid category. Basically what this defines is the type of element and what it should do. So we have a category for missiles, so all missiles will do such and such, and then we have the same thing, all asteroids will do such and such. And we have a bunch of them. We're defining a bunch of categories. We have small asteroids, we have medium asteroids, and if you see this OR, this bar right here, this pipe operator, that means if either of these, if the collision masks, so basically if either of these are present in the actually that's not what it means. What's this pipe operator? Let's ask ChatGPT, because I honestly forget that, and part of what we're doing is just learning this framework, so no shame in just asking ChatGPT what that is. So let's go back to our conversation here with ChatGPT. we're going to ask it what the pipe operator does. So let us straight up just copy and paste our question. So we'll say, what are we going to say? We'll say, what does, oh, this keyboard is so awesome. What does the pipe symbol, I don't know if it's an operator, do in this statement? And we're going to paste. If ChatGPT would please start working. It wasn't working for a while, actually. There's a statement by ChatGPT on X, formerly known as Twitter, and their Instagram, that ChatGPT, Sora, and I think something else was down, one of their other properties. But yeah, it's back up again. As you can see, it's generating a response right now. So ChatGPT says the pipe symbol in Swift is a bitwise OR operator. It is used to combine two integers, including uint values like bitmask, by performing a logical OR operation on each corresponding bit. In the context of this statement, the pipe operator combines the bit masks for the missile category and the asteroid category. This allows you to create a new bit mask that represents a combination of both categories. Okay, so it just combines two different uints. And that makes sense because we have separate uints for the bit masks. We've defined the uints up here. And by the way, uint is just the data type. So here's our uint, which is some sort of binary or whatever. Some kind of data type. But we have, this is a number, a uint, and the bitwise OR operator is combining whatever two categories we have. So say for example we have the missile category that has this value for its uint, and then we have the asteroid category that has this value for its uint. Well, the bitwise OR operator is combining these two, and when you get the unique combination of these two, it's going to produce a certain result. It's going to instruct the code to handle the collision a specific way based on the fact that these two specific physics bodies collided. So that's the way it's working. So it's good that we check that out and ask that question to ChatGPT. So it's kind of messy the way we have it right now. Let's get back to where we were. Okay. Sorry, I spit out my gum. So this function is a compound else if statement, or an if else statement. Else if we have different if statements for the different combinations of the different categories. And then depending on which combination we have different functions that we're calling. So in this first if statement, this guy right here, this first if statement, we know that what bodies collided are the missile and the asteroid category, aka the large asteroid. So if we're inside this first if statement, then we're going to call this function right here, which is to handle the collision. So let's see the definition here. Okay, it's right here. So missile did collide with asteroid. Missile did collide with asteroid. So we just, I don't know why we're doing this, but we have a call here which calls this, which then again calls split asteroid, and split asteroid is down here. And it looks like we have another if-else type thing going here. And we have separate cases where we want to do separate different things. So so here we're removing the node, so that makes the original asteroid disappear. And then we have the case where we have a medium asteroid. What are we doing here? Okay, this is... Okay, without getting too deep into... Actually, let's get deep. You're asking... we're supposed to be learning. Okay, let's get deep. So we're creating a texture, which is an intermediary step before an image goes into a sprite node. So we're grabbing this image, which is an asset that we have in our library, our asset library. Let's go see our assets. Image, medium asteroid 1. Where's our asset library? So this is... Where is it? Okay, so we're grabbing this image called flipped ass from our assets library. Flipped ass is in our assets library right here, flipped ass. And then we are putting that image, which has been saved here, into a texture. That's going into a sprite node. And then we're setting all the different properties of the sprite node. The anchor point, the size, position. We're setting a velocity at random. So that means a random speed, random direction. Then we're giving it a physics body. And we're setting all the properties there. So we're essentially creating a medium asteroid, and then right before we finish, we're giving it a category, one of the uints that we defined earlier. So the previous function that handles the collisions can recognize this as one of the items in the category. And down here we are putting the node, which is also known as the medium asteroid. We're putting that node into this right here. This is a dictionary that keeps track of the live asteroids on the screen. It's just an easy way to manage all the asteroids that exist on the screen if we have it in a collection, and the collection we've chosen to use is a dictionary. So that's what's happening there every time we're calling split asteroid. And actually, you know what? We're creating one medium asteroid up here, and then we're creating the second medium asteroid down here. So within one function, one method, we are creating two separate asteroids, and that is because a large one breaks into two medium ones. And then we're doing something we don't like here, which is calling this missile did collide with medium asteroid. So we have separate functions. This is basically doing the same thing as this guy right here. So we have missile did collide with asteroid, and then we have missile did collide with medium asteroid. See how that's a little bit redundant? What we want to do is we want both of these to be consolidated into one function, and then depending on some certain characteristic of whatever asteroid is being passed into it, within the function make the distinction to act differently. So again, we have this redundancy here. We're splitting the medium asteroid and we're creating two small ones. And yeah, so that's really messy. So how do we get all of this functionality into just one function and have that function understand what to do depending on what type of asteroid it is? So first thing we need to know is what type of asteroid it is. So each asteroid needs to have some type of identifier on it to tell the function whether it's large, medium, or small. Right now, what I could think of is the bit mask. So all the physics properties are created onto the sprite nodes, aka the asteroids. Let's say right here. Yeah, so in this function, this is kind of like a cascading effect. So a really quick recap. We are generating the asteroids. We are giving the asteroids a category bit mask. Then, when we create the medium ones, we're giving those category bit masks. This time, we're giving it the medium category bit mask. And then, when we split the mediums into small ones, we give it a small category bit mask. So, at the very, very beginning, right, when we first generate a large asteroid, we're giving it a large asteroid category bit mask. Right? So that can serve as the identifier, and that also makes sense because we're working with the category bit mask in the collisions, right? So that can be our identifier. That's how we distinguish between large, medium, and small. We just have to remember to assign medium to a medium, and then a small to a small. So a medium category bit mask needs to be assigned to a medium asteroid, and then a small category bit mask needs to be assigned to a small asteroid. So that kind of answers our question in the to-do. So let's just write some notes because we just talked a lot about it. And we want to make sure that we remember all of it. So we'll just say we will use the category bit masks we are currently assigning. We will use the category bit mask we assign to each asteroid as they are generated, and the bit masks are further assigned. Oh, that's my alarm. The bit masks are further assigned to medium and small asteroids depending on their size. We will use the category bit mask we assign to each asteroid as they are generated. We assign to each asteroid as a unique identifier. As an identifier to fire that a function, I like saying method. I mean, it is a method because Swift is all class-based. If we're inside of a class, it's called method. I don't know. That's just how I was raised in the computer science world. Okay, my alarm is just going to keep going off, so let me just turn that off real quick, guys. It's alright to tell me what you think about me. Alright, so we will use the category bit mask we assign to each asteroid as an identifier that a method can use to handle collisions differently depending on the bit mask. The bit masks are further the bit masks okay, I can't talk right now, but that first sentence is fine. We'll use the category bit mask we assign to each asteroid as an identifier that a method can use to handle collisions differently depending on the bit mask. We just need to ensure that we assign category bit masks whenever we generate a large, medium, or small asteroid. Okay. So what we want to do, we want to consolidate all the generation. What can we consolidate here? We want to consolidate the splitting. We want to consolidate the splitting of the asteroids at least, and then, where is it? We want to consolidate the splitting of the asteroids for sure. And as far as the generation, I don't know if we should generate the asteroids. Yeah, I think it would be fine if we just use one function to split asteroids no matter what size they are. So that'll handle the collisions. And then from the split, if it's a large or medium, we can call a separate generate asteroid, and depending on what bit mask we send to the generation one, it can make a large, medium, or small one. So that's what we can do. So let's write that down, make sure we don't forget that. So where are we? Okay, so we want to consolidate all the collision handling, aka what to do when a missile collides. We want to consolidate all the collision handling related to asteroids being shot by a missile into one method that can handle all three cases of large, medium, and small asteroids. And then we'll say from basically this this collision handling method will will execute the splitting of the asteroids. From the splitting method, aka the collision handling method, we will call an asteroid generating method that generates the appropriate sized asteroid depending on what bit mask, what category bit mask we send to it from the splitting. Well, we send to it from the splitting method. Okay, so that gives us a good goal. God. So, I hate to cut it short, but I really have to go to the bathroom, and that's unfortunate right now because I really want to implement this. But also, I have to get up at 5 o'clock in the morning, so I need to be in bed in like 50 minutes, so I need to get ready to bed. So it just happens to work out that I need to go pee and stop this video because we should stop right now. But yeah, we thought about what we're gonna do. I think that's a good strategy for next time. So I'll go ahead and cut it here. I appreciate you guys. Let's go ahead and just commit. So we'll say decided to consolidate splitting of different sized asteroids into one method, then call an asteroid generation method that generates the proper size depending on the bit mask we send to it. It's a little long-winded for a commit message, but we're gonna do it anyway. There we go. So let's go ahead and push. Let us push up to GitHub. Push up to GitHub. Push up to GitHub. Push up to GitHub. All right, come on, GitHub, don't be slow. Okay, today is Thursday, September 26th. We have a commit. Yeah, dude. My commit history has not been very good for the past 5 weeks. Last week it was okay. We got 6 out of 7 days. But yeah, it has not been very good in the past couple months. But anyway, you can't let that get me down. The best time to plant a tree is today. No, what is the adage? The best time to plant a tree was 20 years ago. The second best time is today. So let's plant that tree today. All right, guys. Thank you again for tuning in. Like always, make sure you smash, destroy, annihilate, decapitate, decimate, and obliterate that subscribe button. Peace out, and I'll see you next time.